Hello, we are Team 4 in ME 452 session of Spring 2022. This is our interim presentation of the analysis and redesign of a tape dispenser. I am Richard Zovner.
I'm Nicholas Bowden.
I am Nick Russell.
And I'm Kyle Zabel.
So our product is a packaging tape dispenser. It is designed to easily use packaging tape and roll it across products and cut the tape while rolling it. So the general function of this product requires that the roll of tape is held by the roll core. Then it feeds tape down underneath the roller over here and feeds it up to the blade, where the operator will then be able to cut the tape by pressing the blade into the tape. The target customers are people that want to make the process of taping things easy and might need to do it often, and our production volume target is 100,000 units per year. This is a exploded view of our product. Again, main components are number 3, the roll core, number 2, the rubber roller, and number 6, the blade. We do have a lot of fasteners that we are interested in replacing, as well as spacers, because they do not serve any functional purpose. Our primary customers are non-frequent tape users, perhaps people at home that might need to tape boxes for moving and then not use it again for a while. And our anticipated production for this group of customers is 80,000 units per year. Our secondary customers are people that need to use it often, probably professionals in shipping industry or something like that. And for this variant, we want it to be more durable, but we will produce a smaller quantity of 20,000 units per year for this.
So for our tape dispenser, its main function is to dispense tape, and its two main sub-functives are to cut tape and rotate tape, and it achieves 3 of the 4 sub-functives. And these are the fishbone diagrams of the assembly sequences, with the sequence 1 being on the left and sequence 2 being on the right. Sequence 1 was decided to be more efficient overall, as building on the base plate leads to a larger base for assembly compared to the side plate in sequence 2, which would result in easier handling and assembling in general.
The parts with the most important features are the blade, which cut the tape, the roll core, which holds the tape, and the handle, which provides comfortability to the tape dispenser. As you can see on the function component mapping matrix, the spacer has no function, which means it should be eliminated in the future. Here is our bill of materials and cost estimate for each part. It should be noted that the lower handle is machined, making its price very high. As it can be seen, it's $8.52, which is more than half the cost of the assembly. We should probably redesign this to injection molding. The category on the right is for the functionality and price relationship of each part. The eliminate ones are parts that have no functionality, no matter the price, which can be seen by the spacer, which has low price, but still has no functionality, so it should still be eliminated. The redesigned parts have high functionality, but high cost. And the parts that we should keep are the parts that have high functionality and low cost. It should also be noted that the bill of materials 2, which is for our secondary customers, is higher than the bill of materials 1 cost, which is for our primary customers.
Here's our functional differentiation table. For both customer groups, both variants will have the same functionality in terms of rotating the tape roll, cutting the tape, and pressing it down to seal, as well as they will have the same aesthetic value. The functional differences between the groups appears with an increase in durability and shearing ability for the secondary customer, as they will require more frequent use of the product and will also require a higher durability product. Thus, the second variant will be more durable and it will shear tape more smoothly. That being said, the only parts that will differ between the product variants are the base plate and the cutting blade. All of the rest of the components will remain common between the two product variants as we have listed.
To achieve greater stiffness and durability with base plate for our secondary customer, we switched the manufacturing method from being an assembly with sheet metal and spacers that are screwed together to a single piece die cast component. This also increases the reliability by removing the fasteners which may come undone during usage. With our second variation, we achieve greater sharpness and durability in the blade and greater reliability of the blade by removing fasteners here as well. We do this by using higher quality materials and more expensive processes to manufacture the single piece blade. We ensured compatibility between the two variations and modules by ensuring that the spacer pockets remain the same size and position in all of their locations. The side plate has the same screw hole mounting locations for both of the base plate options, and the tab slots remain the same for the mounting features that are necessary for the blade.
Here, our standard assembly sequence is from the more efficient fishbone diagram, which has the base plate being assembled first, which has two variations. So two variations exist at the beginning of the assembly. And then from there on, it's one variation for the lower handle, soft grip, and so on until the blade holder, which has two variations, and the blade, which also has two variations. So for our delayed differentiation assembly sequence, we moved our base plate to in between the soft grip and the tape guide. We did this to allow one variation only at the beginning of the assembly, but we had to put the base plate after the soft grip because we wouldn't be able to assemble the rest of the packaging tape dispenser.
This concludes our presentation of our packaging tape dispenser. Please buy our product. Thanks.
Thank you.
Thank you.